So, thank you so much for taking the time to speak with me today, YanFei. And to give you a bit of context, my name is Annie, and I created the website Sustainability Beyond the Lab. And the core mission of it is mostly to showcase these sustainable technologies as well as these barriers that prevent these incredible innovations from being widely adopted. And I would love to jump right into your research. So, could you kind of give like a brief background on yourself as well as your work, especially as a postdoctoral fellow at the Cornell Atkinson Center of Sustainability?
Yeah, thank you so much for the chance. It's my first time doing an interview with a high school student in the United States. My
Yeah.
background is that I am doing my second postdoc here. I graduate my PhD in the Tongji University, Shanghai in 2022. And then after that, I did 1 year and 8 months in the Hong Kong as a postdoc fellow. And then in the 2024 March spring, I came here for my second postdoc position at Cornell, work with Professor April Gu. My whole research project is about discovering a new microorganism candidate, which can be functional to do the polyphosphate. Actually, it's for the uh, phosphorus recovery as the polyphosphate.
Mhm.
And we luckily, our previous lab mate found our new microorganism candidate. So I continue to do this bottom-up research. I want to do the scale up and the optimization is the performance. So before that, I did a lot of fundamental research using actually around 1 year for the batch tester to test which condition, which science functional mechanism, metabolomic pathway can help me to target it, upregulated or downregulated my interesting pathway. So it's like synthetic biology and system biology, and also coupled with the wastewater treatment bioreactor set establish and scale up. About this fellowship, actually is ending now because it's already 2 year.
Oh,
Yes, this summer actually July at the end of July this postdoc fellow
mm,
will end it. So thank you for the timing here uh, to do this
yeah,
interview. Thank you.
yeah. Um, yeah, like more specifically about your research, is there any kind of problem that you're aiming to address, as well as how does your research kind of bridge a solution to that problem?
Yeah, thank you for that question. Our whole project, I think, is goal oriented. So the most challenge is that our goal is multiple.
Mhm.
It have at least three goals. One
Mhm.
of that is for the greenhouse gas mitigation, especially for the methane as well as the nitrous oxide N2O.
Mhm.
And the second thing is that we are facing very challenging to do the special wastewater treatment. Is for the manure digestate wastewater. It have like at least 10 times higher than the 10 times higher the ammonia as well as the phosphate
Mhm.
than those traditional municipal wastewater. So it's high strength. And the third goal, we also want to do the resource recovery. So we want to achieve three goals in one system integrated. So
Mhm.
our goal is not it's ambitious. So
Mhm.
that's the one of the beginning challenging. So based on that, I decided at the very beginning, my strategies is focusing on the machine. The machine is the only carbon and energy source for my functional microorganism, like I mentioned, which is also the new polyphosphate accumulation organism candidate our previous lab mate found it. So based on that, I can uh, make a downstream the all the multi-omics to explore the potential.
Hmm.
So that is the part for the fundamental research challenge because uh, if you are familiar for the synthetic biology or system biology, it's like treating the organism like the electrical um, network. It can widen several multiple knot points and a lot of signal the proteins and can call
Hmm.
other proteins. Yeah, it's complicated, right? So our strategy is focusing on the energy metabolism.
Hmm.
uh, one more spoiler alert or hint I want to mention about that because our product is polyphosphate. The precursor important for it is ATP, and ATP is the
Hmm.
microbial energy currency. So follow on that, focusing on that, we found a lot of interesting things. And luckily, finally, we just fire a provisional patent based on the scientific discovery and my
Hmm.
lab scaled optimization strategy. Another very important, very challenging for me is that because it's new strategy, so I do not have the template. I need to
Yeah.
settle up, yes, from the zero. So how to design the whole system, how to achieve that, like the bioreactor, how to feeding the machine, and how to pump those wastewater with the dissolved machine into the reactor, and
Hmm.
how to collect, separate the resource. Those like the a lot of the scale up power and troubleshooting, and also you need to consult with a lot of people who are more familiar with the mechanical and the reactor modeling, something like that. So it's like the challenge is on the bridge linked to the science and linked to the engineering.
Yeah.
Yeah, that's
Your work
it.
sounds very unique. It has like three different goals, as you mentioned. Um,
Yeah.
has there been any kind of previous research that is maybe focusing on one of those goals or anything that like inspired this work?
Oh, that's a good question. Actually, we found a lot of work can for the nitrogen removal, nitrogen
Mhm.
management. People already use the methanotroph, which is the machine-eating microorganism.
Mhm.
Nowadays, we also found out it can do the polyphosphate accumulation.
Mhm.
Before our study, people highlighted that the methanotroph can treat the ammonium partial nitrification and then the denitrification. So it's very helpful for the nitrogen, either as the source recovery, which somebody proposed that N2O can be an energy product, can be recovery generate. And
Mhm.
other people think the machine can be the alternative electron donor to enhance the denitrification, which means the reduce those N2O, reduce the nitrite and nitrate. So we can find a lot of for the carbon and nitrogen. Those link we can find out for that. But
Mhm.
for the polyphosphate, it's the I want to say we are the one of the person, one of those people focusing on the polyp recovery from the
Mhm.
mesotroph. I'm not sure we are the first, but based on our preparation for the provisional pattern, we think our group is the first one to
Mhm.
pioneer for that.
Yeah.
So so the example is not so direct.
Mhm.
Those experience, you can check those redox reaction, those energy metabolism, but you need to switch to your framework. You need to establish a new metabolic framework based on your target products.
Yeah.
Yeah.
Cool. Um, what do you see as kind of more moving on to like scale up? What would you see as kind of the biggest challenges to scale up of this like technology that you're creating? Is it more kind of economic based, the
Uh,
scientific innovation itself, policy based, just kind of in that realm?
Yeah, that's a good question. First of all, we are trying to tackle the problem is about the feasibility,
Hmm.
because the machine to limit the mass transfer is one of the problem. We can find out that the machine dissolve is not those capability is limited. It's not so easy to make it saturate, dissolved. You need to make sure that the proper pressure, the temperature, and actually in the engineering environmental, you cannot change a lot because it's from the wastewater, and
Hmm.
especially for the manure digested wastewater. So actually, we are treating the remaining dissolved machine. So I think the first one is that we need to understand in the engineering, in the real wastewater situation, what is the problem and what is the source we can get.
Hmm.
Yeah. Based on that, we do a lot of survey. We need to decide our strategy based on the background. That's one of the things. The problem, also the opportunity. The second thing is that the scale up is also about the policy and the economy,
Hmm.
like I mentioned, because there's no template for the pea recovery from the manure
Yeah.
wastewater use the methanotroph. So basically, it require a new uh, plug-in reactor or plug-in system. So you need to make sure those farmers, those extension scientists will be happy to use. So we talk a lot about that. In my project, I have an external supervisor in the EDF, Environmental
Hmm.
Defense Fund. My external supervisor give me a lot of helpful information for that because he know a lot of background in the real application. That helped me a lot, which I can decide which is not feasible, which is feasible.
Yeah.
And then for the economic one, our recent current strategies is running the model for the TEA model and the LCM model is for the technical economic analysis TA
Hmm.
model, and we assumed there's 1,000 cows or to 5,000 cows.
Hmm.
How much phosphate, how much manure we can get every day, and but that is still require at least one pilot scale to make a demonstration to confirm our hypothesis it can work. So for the pilot scale, I can say we are in the process and we
Hmm.
are also actively apply those scale up funding to support our project. Yeah,
Yeah.
thank you for your attention and interest.
Yeah. Um, then kind of moving on to like in the future, looking ahead maybe 10 to 20 years, what advancement in your technology or in sustainable innovations in general do you find the most exciting or have the most potential?
Yeah. We recently we imagine a lot. During our brainstorm, I think one of the first thing is that about the carbon credit because we are treating machine and it's the unused machine. So it
Hmm.
means that if we do not treat that, do not recover that, it will just escape to the atmosphere and it
Hmm.
can uh make the climate change worse and worse.
Yeah.
So and we check a lot of the policy about the carbon credit trade market during the whole United States, and we found out that in the California they have very strict policy and market.
Yeah.
Oh, yeah, but unfortunately we are in the Northeast region. It's not in
Hmm.
the California, so
Hmm.
we are thinking about how to make the credit trade, how to make that happen. We are thinking about that, and we are also funding other states. Also, is planning to propose those policy about the carbon credit. So,
Hmm.
one of the most revenue is for getting some money from selling those
Yeah.
carbon credits. Yeah, and second thing is that we want to either settle up a company ourselves, or we can cooperate, or we can sell our licensing to some food waste treatment company, because they also need to use the anaerobic digestion every day to treat those food waste. And especially during some urban, they do not have enough land to make the landfill treatment to dispose of their food waste digested. So if
Mhm.
we can couple with those food processing train or those dairy train, like I mentioned, we are currently focused on the manure is for the cows,
Yeah,
right?
yeah.
So uh, hopefully we can find an industry partner, and then we can do the wastewater treatment benefits for that. So they do not need to pay the downstream
Mhm.
costs to treat those digestate.
Yeah.
Yeah, and the third thing is that we are thinking about recovery some value-added products. First of all is the fertilizer, because the polyphosphate is a very good fertilizer. It's slow release and
Mhm.
it very helpful for those long-term soil health. And we also from those multi-omics, because we see the gene expression potential,
Mhm.
we assume there's still a lot of other value-added chemicals we can recover, but that's it, still in the processing to confirm it.
Mhm.
Yes,
Yeah.
that's it.
And then last question. Is there anything that we didn't get a chance to talk about during this interview that you think is important for like people to know about sustainability or in general?
Yeah, the sustainability, I think, because we are now in the angle of engineering, it's
Mhm.
like the sustainability is not nature-based. We are trying to control, we are trying to push it forward.
Yeah.
So yeah, I think the first thing is that to target it, the right machine source as well as the nitrous oxide source, and then made all the system close. And then we also need some support from those quantification, likely measure, online measure, or sensing
Mm.
those greenhouse gas. Yes, we need a lot of technology and also data support to make the whole sustainability is uh, can be calculated, can be transparent to see their effect.
Mhm.
And about the resource recovery, because right now we're focusing on the resources for the agriculture beneficial, we also need long-term, at least 3 year, at least three run to test it, to confirm it. So I think it's a good start, it's a good idea, but
Yeah.
it requires some time, require a lot of the support. Yeah, we we are trying to we have a lot of enthusiasm, but we are still in the way for that.
Yeah. Thank you for taking the time to do an interview with me today. It was really interesting hearing your research about like wastewater management as well as manure treatment. And yeah, it was great hearing your perspective on on scale up as well of these technologies.